No. When we had the trimester exams, we just have 2 in the morning and then we could go. The finals are just 1 a day for 6 days.
Do we have half days?
Yes, yeah. So the midterms, when you have midterms, it'll be 2 exams each day. You do have to be in dress code, but once you're done, you can leave. So if you if on some particular day we happen to have you happen to only have 1 exam, you don't need to be there for the other one, then you're done for the day. So it's just in the morning. Usually the way that works, I'll have to check the calendar for this year's, but usually the way that works is the Monday of that week will be a full day of classes. That'll be a review day, and then you'll have exams Tuesday, Wednesday, Thursday, and then Friday. If you missed any exams for whatever reason, you would come in then and take them on Friday. But otherwise, Friday's off. That's generally the way that midterms work. I don't know if there have been any adjustments made this year because of everything going on. Hopefully, we'll still be in person then, but no guarantees. Questions, comments, concerns? Don't worry too much about midterms. The reason why we do midterms are sort of twofold. One, because in general it's good to get used to taking these larger exams. When you get to college, that's usually the way that those exams are structured also. But also, the reason why they're useful from a pedagogical standpoint, from a teaching perspective, is imagine you just have, all throughout the year, you just have like a little quiz every week, and it only covers the stuff from that week. For seeing how you're doing in terms of the current week's material and helping you retain that. But what it doesn't give it good information about is how well you're retaining the material longer term. That's why we do the midterms and finals, because for the midterms and finals, you're having to remember material from half of the year, roughly, or the whole year. And so it's a way to encourage you to take this information and not just stick it into your brain and have it fall out, where it doesn't do you any good except for that single grade, but rather to keep it in there and have it stick around so you can benefit from it longer term. Okay, remember, lesson 33 is going to be due tomorrow, all except 3 and 4. We're going to have test 7 on Wednesday. I do want to finish going over lesson 33 because we didn't finish that last week. So please open your textbooks to page 134.
Oh, it's due Tuesday?
Yes.
Yeah. What? It's really done Monday, bro.
You were the one who said, oh, it should be due Tuesday, so we don't have homework Monday.
I forgot. I don't know why I said that. Because I finished it. God.
Okay, so you remember, hopefully on Friday, we did the sieve of Eratosthenes, this method of finding prime numbers. Remember, what's a prime number?
A prime number
That doesn't have
Counting
can't be
number
divided.
greater than 1 whose only counting number factors are 1 and the number itself.
the smart guy.
Right, the only integer factors are 1 and itself. So other than by multiplying the number and 1 together, there's no way to multiply 2 integers to get to a prime number. 7, for example. The only way to multiply 2 integers, or 2 counting numbers, I guess is a bit more accurate because we're always having positive numbers here. The only way to get to 7 is to multiply 1 and 7. There are no other pair of numbers you can multiply together and end up with 7. Right? 2 and 3 is going to give you 6, not 7. That's what we mean by prime. All numbers that aren't prime, we call composite. Composite. Why do we call them composite? Because they are made up of prime numbers. That is, they have as factors at least 1, well, at least 2 prime numbers besides itself. So 6 is composite. How can we tell that 6 is composite? What can we break 6 down into? And what? 2 and 3. 2, is that prime? Okay, really, please be familiar with those prime numbers, especially up to 30 or so. Is 2 prime?
Yes.
Yes. Is 3 prime?
Yes.
If we multiply them together, do we get 6? Okay, any number that is not prime, we can break down into what are called prime factors. Prime factors. The way that I recommend you do this, factors. The way that I recommend you do this is drawing it like this. Split it into 2 things, and then ask yourself, can I split either one of these further? So we can write 6. If we write it as the product of prime factors, we can write it as 2 times 3. Yes? 2 times 3 is equal to 6? Yes? Okay. But what's useful about it there is it's been broken down into prime factors for you. For example, if we were doing 6 divided by 2, well, 2 times 3 divided by 2 is actually a bit easier because we've got times 2 and divided by 2, and those cancel out. You just end up with 3. Yes, that makes sense? And if we write this, 6 divided by 2, 2 times 3 divided by 2, this is a bit easier because we've got multiplying by 2 and dividing by 2. Those can just cancel out. Okay, anyway, let's do it with a couple more numbers. Yes?
What did it say in all the numbers next to add? To the right of add?
At least.
Oh.
At least 2 prime numbers. Let's try with 12. Let's break 12 down into prime factors. What are 2 numbers we can multiply together to get to 12?
3, 4.
3 and 4. Okay. Is 3 prime? Okay, great. Let's circle it. Is 4 prime? No. What can we break 4 down into in terms of prime factors? 2 and 2. Is 2 prime? Is 2 prime? Okay, so we can rewrite 12 as 2 times 2 times 3. I like to put them in number order. Or,
3 to the times 2 to the second power.
right, we could write as 2 squared times 3. 2 times 2 times 3, or 2 squared times 3, because 2 times 2 is 2 squared. Yes? Question?
Can I go to the bathroom?
Go to the bathroom.
Yeah, alright.
Hurry up. Notice that it doesn't actually matter how we break down these numbers. Notice with 12, we could have divided into, instead of 3 and 4, we could have done 2 and 6, right? Yes? I could have started that way.
Yes.
Is 2 prime?
Yes.
Okay, is 6 prime?
Yes.
What do I break down into?
3
3 and 2.
2 and 3. Okay, notice, I do that. I end up with the same things that I did, 2 times 2 times 3. Because these are factors, namely things that we multiply together, it doesn't matter what order we break down this number in to get to its prime factors. So, let's do one more. Let's do 108. 108 as a product of prime factors. 50?
54 and 2.
Okay, 54 and 2. One easy thing to do is if you notice that it's even, you just divide by 2. There are other things we could have divided this by, but we know that 2 will work. Okay, is 2 prime? Is 54 prime?
No.
No, it's an even number, so it's not prime. If it's an even number that isn't 2, it's not prime.
17 and 2. Wait, no, that's 59.
But 2 and what?
2
27. Okay, is 27 prime?
and
No, 27 we can divide by what?
3 and 9.
Yeah, 3 and 9. 3 is prime, what about 9? 3 and 3, okay. So, how can we write 108 as a product of prime factors? 2 squared times 3 cubed. Or 2 times 2 times 3 times 3 times 3. You see how I broke that down? Each step I'm splitting it into 2 numbers that I can multiply together to get that number. Any that are prime, I can't split those any further, so I stop there and I circle them. That will help me keep track of which ones I've got. Remember, I could do this in any order, so maybe I see this number 108, and I know it's 108. If I add 1, 0, and 8 together, I'm going to get 9. That tells me that I can divide the whole number by 9. What do I get when I divide 108 by 9? No. 9 times 11 is 99. 12, yeah, 12. Okay, 9 and 12 is 9 prime?
No.
What did I break it down into? 3 and 3. All right, is 12 prime? Break it down to what? 3 and 4, okay. 3 is prime, 4 we break down into 2 and 2. Notice we still get 2 squared times 3 cubed. You still get the same thing. What order you do doesn't matter. Notice that if you divide by larger factors to begin with, you're not going to have as many steps down, whereas if you divide by a smaller factor, you're going to have more rows. It doesn't matter though. Either one is going to work fine. Questions?
Didn't we only use 2 and 2? Okay, I'm not, you can use 5.
5, 7, 11. Now if we had 55, 55 divides into 5 and 11. 55 isn't prime, but 5 is prime and 11 is prime.
So, yeah, so like you can write 5 times 11.
Yeah, for 55, the only thing that we can do there is, well, we see that it's with 5, so we know that we can divide by 5. We divide by 5, we get 11. 11 is also prime. The only way to write this as a product of prime factors is 5 times 11. Sometimes it's not going to be as long as those, but sometimes it will. Okay. Let's just take a look at the second section here on 135. A little bit different. Example 33.3. Twice a number is 42 less than negative 102. Twice a number obviously is 2n. 42 less than negative 102. So what do you have to do to negative 102 to make this equation, to write it correctly? How do we say 42 less than negative 102? They say 42 less than something.
42 less than negative 1.
So this is right there, example 33.3 on page 135.
Okay.
Twice a number is, okay, so we've got 2n equals, twice a number is 42 less than negative 102.
42 minus parenthesis negative 102 then.
No.
I get it.
Oh,
What if I said, what's 5 less than 20?
2x minus 42. No, 2x equals.
If I ask you what's 5 less than 20, what are you going to say?
Huh?
What's 5 less than 20? 15. How'd you get that? 20 minus 5, right? If we say so-and-so much less than something else, that's how much we need to subtract from the second number.
I got it backwards.
So, right, yeah, this is what happens. Don't get it backwards here. 42 less than negative 102 means we need to take this negative 102 and do what to it? We need to get 42 less than that. Subtract 42 from it. This is what we need to do here in order to set this up correctly. Twice the number is 42 less than negative 102. All right. Questions about 33? Those of you who started the lesson set, have any that you wanted to go over from there? Okay. Yeah, go ahead. Sorry, I thought I told you yes before. Just giving you a hard time. Okay, page 138, lesson 34, greatest common factor. Is this a topic you feel comfortable with? Yes? I guess so. Greatest common factor. Let's take a look at each of these words. Greatest common factor.
Why are we doing that? It's just a lesson.
What was that?
Why are we doing that lesson? We're gonna get it.
So we can keep going?
Do we have homework for tonight or no?
Yeah, finish 33.
No.
If you already did 33, then yes.
Can I say 33?
What?
Can I say 33?
Greatest common factor. What is the greatest common factor? Each one of these words means something. What's a factor?
A number.
What kind of number?
A number that can be multiplied to equal to a number.
Right, so we were talking about how 108, for example, these are its prime factors. These are the numbers we multiply together to get to it. Factors are the numbers that we multiply together to get a product. What about a common factor? What does it mean for something to be common?
We always get it.
If
Like
No,
two.
like you both have it.
Right, if we have something in common, that means we both have this. It's shared. Communis is Latin for shared. It's a shared factor. It's a factor that two things have in common. And we're not just talking any factor they have in common. We're talking which one of the factors that they have in common? The greatest, right? We're talking about the biggest factor that two numbers share in common. The biggest factor that two numbers share in common. So, what if we have let's see, these examples here are unnecessarily complicated. All right, let's do a different one. We're talking about 108 and 12. 108 and 12. What is the greatest common factor of 108 and 12? Well, let's find it out. So the way to do this is we want to break it down into its prime factors first. So we already broke down 108, and we got 2 squared times 3 cubed. What about 12 when we break it down to its prime factors?
3 times 2.
Yeah. Is the biggest thing that they share in common. Do these guys both share 2 as a factor? Do they both share 2 as a factor?
Mm-hmm.
This is 2 squared times 3, this is 2 squared times 3 cubed. They both share 2 as a factor, yes?
Mhm.
How many 2's do they share in common as a factor? This guy has 2 2's being multiplied into it. This one also has. So not only is 2 a factor they share in common, but 2 squared is also. And we want bigger. The more things we can get in there, the better. Yep.
Wait, can you count yourself? I mean, like 12 is a great common factor. So then.
Yeah. Yeah, so they also share 3 in common. Now, how many 3's do they share in common? Just 1, right? Because this guy, we multiplied 3 3's in to get to 108, but we only multiplied 1 3 in to get to 12. The biggest number that they share in common as a factor is 2 squared times 3, or 12. Remember, every number is its own factor. Probably the biggest thing the two things share in common. Here it's 12, because they both share 2, they both share 3, and they don't just share 1, 2, they actually share where we use variables instead. What if we have this? This is example 1 on page 139. 8 z to the 4th m squared p minus 12 z cubed m to the 4th p. Now, what things do these guys share in common? Just by looking at them, what factors do they share in common? We've got 2 terms here, 8 z to the 4th m squared p, and negative 12 z cubed m to the 4th p. What factors do they share in common, just by looking at them? What?
Nah. 2.
2. Okay, so let's just deal with the numerical coefficients here. 12 and 8. What's the greatest common factor of 12 and 8? You say 12 is 2 squared times 3. What about 8? What's 8?
4 and 2. 2 and 2.
So we can rewrite 8 as what?
2
2 squared times 2.
2 cubed. Yep. So what's the greatest common factor of 12 and 8?
4.
4. Because they both have 2 copies of 2 in common. 2 times 2 is 4. Okay.
Isn't it negative though?
What was that?
The negative.
Negative doesn't matter here. Okay, 4. The greatest common factor of 8 and 12 is 4. What else do they share in common besides 4?
3. Sorry.
Z cubed. Right? They both have z in there being multiplied in. This one has 3 copies of z. This one has 4. We have to go with the smallest number. Because this guy only has 3, so it can only share 3 with this guy. Yes?
Yes.
Okay, what else do they share in common? M squared. Notice they both have m in common. This guy has 2 copies of m being multiplied together. This one is 4, so they only share 2. You always have to go by the smaller exponent. And then, what else do they share in common? P. How many copies of P? Just 1. They each only have 1 copy of P. There's your greatest common factor of these 2 terms. Notice we go through each of those parts, the numerical coefficient, the 8 and the 12. We find the greatest common factor of those. And then we find the greatest common factor for our variables. What would happen with the greatest common factor? Let's say that one of these guys didn't have P in it. If one of them has a variable that the other one doesn't, then what do I need to do, change about my greatest common factor? What's my greatest common factor going to become if this guy doesn't have P in it? Can the greatest common factor have P in it if one of these factors, one of these terms doesn't have P in it? No, because they can't share P in common if one of them doesn't have P.
I don't think I want to share P.
If one of them has a variable and the other one doesn't, then they don't share that variable. It shouldn't be part of your greatest common factor. If they do share a variable, you need, as a factor, you need to ask yourself how many copies of that variable, how many copies of that thing is a factor they share. Here, this guy's got 4 copies of Z, this one's got 3. So they only share 3 in common. They can't share 4 in common because this guy doesn't have 4. They both share M. How many copies of M? This one is 2, this one is 4. They can only share 2 copies because this guy doesn't have 3 or 4. We want the greatest. We want the biggest number that they both share. Yes, it's true that M is a factor of both of these, but we want the biggest common factor. We want we want to combine as many factors that they share as possible. All right, so 34 will be due on Thursday. Because 33 is due tomorrow, and Wednesday's our test. So problems at 34. No, wait. There's one that we skip in here. No, it was 32 that we skipped. All right, 34 is going to be the same deal.
We never skip 30 stuff.
34 is all except 3 and 4.
Wait, how many of them are like that?
Let's see. That's going to be due Thursday. All right. Bye.